So, small tutorial about this T-journal camera, about the hardware. So here is the case, so bottom top, and the button that will allow to press on the reset button of the board to switch on or switch off if there is battery connected. So first, why the T-journal? Mainly because it have external antenna connector, which is very convenient, because on other boards it's possible to modify it to get external antenna connector, but it's not very convenient. As second interest, we have lithium battery connector. We can charge the battery by the USB and start the board, as I said, with the reset button when only the battery is connected. So lithium battery, it means LiPo or Lion. So this is one Lion battery. Of course, it's optional. Maybe you don't need it. I don't know. But it can be, it's cheap because you can find this everywhere. Mainly in laptop batteries. So I show you. So I take this on, it was HP laptop probably. Old battery that we didn't use for a very long time. And this one is from one Acer computer, and as you see, it's similar, it's the same. So, when you order the T-journal, you have of course the board, camera on one side, scanner on the other side, antenna, and this cable with connector that you can use or not, if you need or not, to connect battery. So first, we insert this, the side button. Okay. So, if you don't use external battery, you can just put like this, close the end. But I need it. I need support to handle well this to do a good job. Okay. Okay. So, as you see, I connect only the black wire for the moment, other side. Why? Because when we insert the board in the enclosure, we can by mistake press the reset button. And when you insert the board, the antenna is not connected. If battery is connected and you press reset button, the board starts without antenna and you can damage it. Okay. So we need again small support. Now I have to solder the positive. Okay. I didn't prepare the glue gun, so it needs to heat up fuel before. During this time, let's talk about the battery. When I took this battery from the pack, the voltage was 0.07 volt. So to me it appeared probably broken, but I wanted to try to save it, and for this I use one cheap Arduino Uno clone from China. As you know, LiPo or Lion, like this battery, have nominal voltage of 3.7 volts and maximum of 4.2 volts. To supply this board, I use one phone charger, 5-volt phone charger, but in reality it's a few more. It's usually 5.2 or 5.3, something like this, 1 amps. And I connected the battery to ground and to VIN header. As you understand, I put 5.2 or 3 volts on battery which has maximum voltage of 4.2 volts. It was purely in IEM to make, like a shock therapy to resurrect the battery. Of course, as you know, LiPo or Lion battery can, when they are damaged or just old, when you charge it, they can become very hot, burn, or even explode. So you must be very careful if you do this. So I connected to VIN during 1 minute maximum. It's just to, remain to resurrect the battery. And as result, it was approximately 2.6 volts at the battery pole. After this, I remove from VIN, I put to the 3.3 volt connector header. And few by few, it takes very long time, but the voltage of the battery rise up to 3.3 volts. When this was finished, I leave it rest few, and because it remained to acceptable tension, to acceptable voltage to connect to LiPo Lion charger, I started to charge it with my iMax B6, but you can use, of course, any LiPo Lion charger which is made for this purpose. And it takes a very long time to charge it, but I totally charge it. And as a result, the first battery I charge, the first Lion battery like this I charge, I put 2184 milliamps inside, and the second 2117. So it's 2200 capacity when it's brand new, and my LiPo Lion charger charge nearly the same. However, these batteries are used, and I see that this one, for example, was charged to 4.2 volts by the charger. When I remove, it was already 4.09, and now 2 or 3 days later, it's already 3.9 volts. However, for my use, I don't believe the board will have a very big consumption, and I don't need it to run for a very long time. I need 2 or 3 hours. So for me, it's okay. The glue gun. Okay, we start to have a glue. But the most important for me is to block the Lion battery so that it won't move inside the enclosure. Then to screw it, we need 4 screws. This one it's M1.5. It's probably the suitable size to screw, but I have only one, so I can't choose. And I have this M3. With this M3, you need to drill to M3 here, so that it's free to go inside, and here to 2.5, I don't remember exactly. So now I install the cover. Okay, so it's ready, and as I said, if you press once, the board starts. You press twice, switch off. If you connect the USB, of course it also switch on, and at the same time it charges the Lion battery. So for my use, in fact this one is camera and this one is receiver. Okay, let's start this small software tutorial. First, where to buy the board. Liliego.cn, you find the T-journal and you click buy now. You arrive on AliExpress. This is in Spanish, I don't know why. Take care that you select the normal lens. Of course, you need 2 boards. One for the receiver and one for the camera, and you can buy. If you don't take the normal lens, you will have problem because the enclosure is not made for, and anyway the fisheye lens it's not very suitable to read target. Then you need to install Python. I have this version. Maybe it works with another, but I have this one. I use this installer as I have Windows on 64 type operating system, but of course you have to select which one is correct for yours. You must install Arduino IDE that we will use to program the board. There is new version, but I have this one. I don't know what the difference. Maybe it works also. No idea. And I use this installer Windows 7 and newer, if I remember well. Then you search on the web run a target camera. You should find this and arrive here, or maybe on the main page here. You select run a target camera long range GSP no cam. Come back here. You click code and download zip. When download is finished, you get this file. You click right, extract everything, and you have this folder. Click and click. There is another zip file. It's like zip in section libraries. You extract also. I already did, so I have this folder. Then you have to start Arduino IDE and you close. Once you did this, you copy this library file, you go to Documents, Arduino, Libraries, yes, you remove and you pass the new one. Inside there is all my libraries. Probably just few of them are useful, but if you have everything, of course you have the good one. Okay. Once all this is done, you can open Arduino IDE. I open just a sketch example to show you. It is basic Blink, for example. Okay. So here you go to File, Preferences, and you have this field in which you have to write something. It's, if I translate well, URL of additional board management. So you will find this under the video, no problem, and you click OK. Then maybe you have to restart the Arduino IDE again, I don't remember well, but you go to Tool, Board, where it is, type of board, Board Manager, and this open. It takes few time to update. Okay, you search ESP32 and you find ESP32 by Espressif System. I have only deleted because I already installed, but of course you click install, and when it's done you click close. You maybe have to close and restart Arduino IDE again, and once it's done, what happens? You click on File, Open. We go to the download folder. It's what we already download. And first, we go to the camera folder. So you open the .ino file. Okay, we can close Blink, and we have this. Then we must select the correct board. So it's already done, of course, but you go on type of board, you go to ESP32 Arduino, and you select ESP32 Vrower module. Everything here should stay the same except the partition scheme, and you must select a JPP, 3 MB NOTA, 1 MB SPIF. For the port, you see that I have different COM port available, but we have to go what's this? Device manager, probably the name in English. Okay, it open. Too long, and you go to port common LPT. You have all COM port available. Here it's all Bluetooth, nothing else. When you will connect your board by USB, something will appear, and probably on mine, if I remember well, it is COM10. You see there is no COM10 here. When you connect, COM10 appear. You remember what COM appear, the number. Mine it will be COM10, but okay. You close this. You go to Tool, Port, and you select, of course, COM10. I don't have here because my board is not connected. Okay, and then when everything is ready, don't forget to change this. And it's the name, it's written, the Wi-Fi network name. Your receiver will connect on, and so your receiver can connect on, for example, your smartphone, or I don't know, maybe if you shoot at home, on balcony, in the garden, you can put, I don't know, the box of your internet access provider. I don't know, just an example. Okay, it don't need password because it don't really connect on. It's just to capture one beacon frame and to set the correct Wi-Fi channel. Okay, and then when everything is ready, you can click compile here, and you see that the status bar start to grow. It should take long time, so it will end soon. And okay, compilation success. Compilation is over. So no problem here. If there will be a problem, here it will appear orange, and the problem will be described here, and then you will have to find why. But here it's okay. And then you just have to click upload to the board, and it will compile again faster. It take I don't know, probably 5 minutes here. It's long, but it will be faster because you already pre-compile, and it will compile again and then upload to the board. Of course, before you connect the board to USB, don't forget to put the antenna. Always put the antenna. It's the most important. You can damage the board. When this will be ready, first on the screen of the camera you will find the MAC address of the camera. It's a kind of ID of the board of the equipment itself. And then we must open the other file, which is the receiver. .ino. Okay, I can close camera. So for the receiver, it's nearly the same stuff. Here you must also change, it's written, the Wi-Fi name your receiver will connect on, if it's your smartphone or the box of your internet provider. The password, because the receiver really connect on it. And here is the MAC address. It's what I told you just before. Here you must enter the MAC address of the camera. So here is an example of MAC address, the example of what you will see on the screen of the camera. You see 10, you write here 52, it's here. Then you have 1C, it's here, okay, etc, etc. So you need absolutely this. Local IP. It's where you set the static IP on which the receiver web page will be accessible. That means on the browser of your smartphone or on your computer, you will type this address to get the picture and signal of the camera. This address will depend of your device. Usually, the access point, your smartphone or your box, will have this address. Usually, it provides that kind of address to the device, but it depends of the access point itself. For example, for my smartphone, it near address more similar like this. So this you can check, for example, when you connect, if you want to connect on your smartphone, for example, you connect your computer and you check the address with software I will put in link below this video. And you check what kind of API the access point give to your computer, and you know it will be similar for the receiver. So you give a similar address, and then you test. You just upload the sketch, and you will see if what you choose is correct or no. What else there is to choose here? So anyway, it's written here, SSID and password, local IP, sender MAC address, and antenna gain. Yes, antenna gain. Where it is? It is here. So the antenna you get with the T-Journal, it's 3 dB type, it's basic. In Europe, we have a restriction for antenna over 6 dB gain, you must lower the power. It's not really important for the performance of the system, because you must understand there is two kinds of link, ESP-NO and Wi-Fi. On ESP-NO it is unidirectional, the transmitter only transmits and the receiver only receives. So you don't need power over the receiver. But between the receiver and your hotspot, between receiver and it can be your smartphone, it can be a laptop, it can be the box of your internet access provider. It is Wi-Fi, so it's bidirectional and it's transmit also. But between the receiver and, for example, your smartphone, it will be short distance. So even if the power is not important, it's okay. Change very few, in my opinion. So then, as for the camera, you need to connect the board of the receiver, find what COM port it is, and select the COM port. As difference with the camera, Here you must, after you select the COM port, click on Tool, ESP32 Sketch Data Upload, and here it will display the sketch is uploading, and when it will be successfully uploaded, not the sketch, the data of the sketch. Excuse me. We can describe this quickly by it's the architecture of the web page. You will have access on the IP address. You can say this like this. Of course, then you have to upload, like for the camera, the sketch. You upload the sketch, it compile, upload to the board. Then you start your hotspot. For example, if it's your smartphone, you start the receiver first and just after the camera, and it should connect. On the camera you will see the MAC address and if it's paired or not with the receiver. On the receiver you will see the IP address you enter here. And if it don't work, that means this or this is not correct. But everything should be okay. So this small tutorial is over now. I said small, but in fact it was quite long, but it's step by step, so you should not have problem. And thank you for watching. Good luck for building, good luck for programming, and good luck for shooting. It was a joke. In fact, just after you will have as bonus test video of 1.3 kilometers. So let's test. This is nearly the same situation than with the previous camera, but we have a little fog. Switch on the receiver. Okay. Switch on the camera. Okay. We are at 840 meters, and with the basic antenna we have picture time to time. Okay, with 11-13% signal. Probably signal is few better because the line of sight is better. Update 6%, 10% position of the mask. Gmap say me 1.1 kilometer, but I believe it's more like 1 kilometer and 60, 70, 80 meters, something like this. We have 0% signal, sometime 1, but picture update. Yes, picture move. That means at 1.1 kilometer with this small stick antenna, and not yet this one, we still have picture update. So with the Yagi antenna, I believe it's possible to achieve 1.5 kilometer minimum, but as you see, I lose the line of sight. There is few descent. This is 1.3 kilometer. The silo is here in the middle of the picture. But I am in the descent, and of course we lose the line of sight. But I will try to put the antenna on the roof of the car and test the Yagi antenna. So we are still at 1.3. The receiver with the big antenna show 11% approximately. And it's difficult to see because it's night now. But it should update. Yes, it updates.